Hello, y'all, and welcome to Dilutions. So Dilutions is our extension of solutions chemistry. So if you haven't watched that, please go ahead and do so. You're going to need a little bit of that info for here. But with that said, let's just get started with the first and most important aspect. We're talking about molarity, which is just a fancy word for concentration of a solute in a solvent. So like salt in water. So that would be molarity. And molarity is figured out with a pretty simple equation. It's just the mole of solute, so however much solute you have, divided by the total liters of solution. Again, I'm going to be abbreviating solution, SOLN. So without further ado, let's just go ahead and look at an example of what a dilution is. Now, just a quick heads up, dilution usually just means to add water. To dilute it. You may have heard of diluting as making the concentration lower, and usually the way you do that is by adding water or whatever your solvent is. So with that said, I'm just going to go ahead and prepare a solution of salt water. So here I've got my solution of salt water. I've got some salt in there. In fact, I have exactly 6 moles of salt, NaCl. And I have 2 liters of solution. So we're going to go ahead and quickly calculate the molarity. So the molarity of NaCl is just going to be 6 moles divided by 2 liters, which is just going to go ahead and give us 3 molar. So right now, that's what my molarity is, 3 molar of sodium chloride, NaCl. So go ahead and just add that in. Now, here's the deal. That's too salty for me. I might use it in cooking. I don't know. Can't think of a good thing. Maybe I'll make a broth, but that's too salty. So I want to dilute it. I want to make it less salty. So what I'm going to do is I've got a quick, easy solution to that. I'm just going to go ahead and I'm going to add some water. I'm going to actually add 1 liter of water. Now that brings my new volume up to 3 liters of solution. Now, something you'll notice is I didn't actually change the amount of salt in here. The salt remains the same. I have 6 moles before, and turns out I actually have 6 moles in here too. So I'll just go ahead and put an arrow there too. But because we've changed the total amount of solution, when I go ahead and calculate molarity again, so molarity of NaCl is still going to be 6 mole, but now we have over 3 liters. And so you'll notice my molarity actually drops to 2 molar NaCl. And this might make sense. If you've ever made like powdered drinks or anything and it's too flavorful, not that anyone could say there's too flavorful powdered drinks, if you add more water, the flavor becomes less. It becomes more diluted, or we would say the concentration goes down. Any of these explanations work. But I want to bring a key aspect to this. So I'm going to go ahead and take all this information and kind of process it right down here in this space. So this is going to be solution 1, and this is going to be solution 2. I'll go ahead and put solution 1 in blue, and I'll do solution 2 in green. Just trying to make it really clear. So in solution 1, the molarity of solution 1 was equal to 6 moles NaCl divided by the volume of solution 1. Now we have numbers for these, but for now I just want to leave it a little more abstract. Solution 2, on the other hand, had a molarity that was equal to also 6 moles of NaCl divided by volume 2. Now you'll notice that our amount of solute is the same. And so I'm going to do a little bit of fancy algebra here, and I'm going to do my fancy algebra in red. If I multiply both sides of our first equation by volume 1. On the right side, they cancel, but on the left side, they just add up. And so our new equation is volume 1 times molarity 1 is equal to 6 mole NaCl. And I'll do the same thing on my right side with my second one. I'll multiply by volume 2 and volume 2. Separate these a little bit. And the volumes are going to cancel out. And I have molarity 2 is equal to 6 mole NaCl. Whoops. And I forgot something right here. Whoops, my bad. So this is now V2M2. And what you may notice is we still have 6 mole and 6 mole, which means we can actually take these two equations and set them equal to each other. I can just set them both equal to each other. Because volume 1 M1 equals 6 moles of NaCl, which also equals volume 2 M2, which equals 6 moles of NaCl. So, turns out for dilutions, we have a formula that tells us everything, and that formula is the molarity of solution 1 times the volume of solution 1 is equal to the molarity of solution 2 times the volume of solution 2. You'll notice I just kind of swapped my volume and molarity just because I like saying M1V1 equals M2V2. And that is the big thing about dilutions. If you got that, then you're good. Heck, you don't even really need to know everything. I just like explaining the reasons why things are. So let's just jump into examples. So if you really needed a example to look at, you can just skip to whatever timestamp this was, but you're already here, so too bad. Example 1. So for example 1, I'm going to say I have a stock solution. Now, stock solution is just a fancy word for a very concentrated solution that you get stock from a chemical company or something like that. And we say this is going to be 6 molar hydrochloric acid, HCl. Now, I can't deal with something that strong. What I really want is about half a liter, 0.5 liters of 1.5 molar HCl. So the question is, how much stock solution do I need? Because really what I'm going to do when I do this is I'm going to grab some stock solution, some liter of stock, and then I'm going to add water until I have 0.5 liters total at hopefully 1.5 molar. So what we're going to have to do is figure out our M1, our V1, our M2, and our V2. And this stock solution, by the way, once again, is 6 molar. So a pretty helpful hint is just go ahead and highlight all the numbers you have. And you can even do that straight in the equation, 0.5, 1.5, and 6. So you want to associate numbers together. That always helps. So we're just going to go ahead and call our final one solution 2. And we'll call our initial one solution 1. So M1V1 equals M2V2. Well, we know that our molarity 1 is 6 molar. Our volume 1 is unknown. That's what we're looking for. We want to find our stock solution. Oops. We want to find our amount of stock solution. So we're going to go ahead and plug in the rest of our values. Our molarity 2 is 1.5 molar. And our volume 2 is 0.5 liters. And now this just becomes somewhat basic algebra. We can just divide 6 molar on both sides. And we get volume 1 equals 1.5 molar times 0.5 liters. divided by 6 molar. You'll even notice that our units M will cancel out, but we'll be left with liters, which is good because liters is kind of what we want our answer in. So 1.5 times 5, 1.5 times 0.5 divided by 6 is going to be equal to volume 1 is 0.125 liters. And that's how much of our stock solution we need. So congrats, you did it. All right. So what we're going to do is we're going to move ahead on to our second and final example. And so for our second example, it's going to get a little bit harder because I'm going to throw in some tricks that you're going to see. So let's say I have 800 milliliters of a 12 molar NaOH solution, sodium hydroxide, and I dilute it to 10 molar. Now my question is, how much water did I add? So we're gonna come back to this part right here at the end, because right now what I really want to focus on is the M1, V1, M2, V2 part. So we want our M1, V1, M2, V2. So I'm going to go ahead and highlight my numbers. 800 milliliters, 12 molar, 10 molar. So something we can automatically see is I have 800 milliliters of 12 molar. Those are associated. So why don't we just go ahead and call that 1. And over here, I have 10 molar. And so that's going to be 2. And we're looking for our V2. So this is kind of what we're looking for right now. So we'll go ahead and plug some of these numbers in. M1 is 12 molar times V1 800 milliliters. Something you'll notice is I didn't change the liters because when you're doing M1, V1, M2, V2, because volume is on both sides, it really doesn't matter what units you use, the units will always cancel. So we're going to say is equal to M2, which we actually know, I shouldn't have written that, is equal to 10 molar times our volume 2. So once again, we're going to do some quick algebra. That's divide by 10. That's divide by 10. We'll keep our m's here. And so 10 molar cancels with 10 molar. I'll just say 10 will cancel with one of the zeros. So we're only dealing with 12 times 80. And so it turns out that we need a total volume, V2 must equal 960 milliliters. Now, here's where I want to be careful. This is absolutely not how much I added. This is our total volume. When we look at this example, we have to be pretty careful because what we're saying is in our first solution, we have 800 milliliters and 12 molar. What we're going to do is we're actually going to add H2O. And when we add H2O, this solution that I'm duplicating so I don't have to draw it again, is not going to be 800 milliliters and it's not going to be 12 molar. We know that it has now moved up to 960 milliliters at 10 molar. So how much I add is really this difference. It is going to be 960 minus 800. So the question is tricky because it's actually asking you for the answer 160 milliliters. 160 milliliters is, in fact, how much I added. So we can say we added 160 milliliters of H2O. And congrats, you now know how to do everything for dilution, so have a great night.